Imagine two molecules enter the ring. Alkane in the blue corner and alkene in the red corner. One prefers a radical rampage while the other loves electrophilic hugs. But why do they fight so differently? Stick with me till the end and you will not only know who wins this battle, but you will never forget why they react the way they do. Hi, I am Dr. N. Swati, your organic chemistry coach. Today it's all about reactivity showdown, alkanes versus alkenes. Chemistry of alkanes. Alkanes are the saturated hydrocarbons containing carbon-carbon and carbon-hydrogen single bonds. The general formula is CnH2n plus 2. Coming to the examples, methane, ethane, propane and butane. These are the few examples for alkanes. Chemistry of alkenes. Alkenes are the unsaturated hydrocarbons containing at least one carbon-carbon double bond. The general formula is CnH2n. And coming to the examples, ethene, propene and butane. These are the few examples for alkanes. Coming to the bonding differences between alkanes and alkenes. In case of alkanes, all bonds are single bonds. That means alkanes are mainly made up of carbon-carbon and carbon-hydrogen single bonds, which are of sigma bonds. So the electrons which are present in sigma bonds will be always strongly held between the nuclei. So hence, these single bonds present in saturated hydrocarbons such as alkanes are very strong and they're very hard to break or undergo any reaction. Hence, they exhibit low reactivity. Now coming to the alkenes, so these alkenes, they consist of double bond. So double bond means one will be sigma bond while the other will be pi bond. As you are aware, the electron pair which is present in pi bond will be loosely held between the atomic nuclei. So that's why pi bonds are considered to be weaker in nature when compared with the sigma bonds. So due to the availability of these pi electrons in alkenes, they are considered to be electron-rich species. Hence, they can be easily attacked by any species which is deficient of the electrons. And that is the reason they exhibit high reactivity. So due to the presence of non-polar carbon-carbon and carbon-hydrogen sigma bonds, alkanes are having low reactivity, while in case of alkenes, due to the presence of pi bonds, they are considered to be electron-rich species and hence they exhibit high reactivity. Now let's see why they will undergo different reactions. So in case of alkanes, due to the presence of non-polar covalent bonds, they are inert to most of the reagents at room temperature. That means neither nucleophile nor electrophile can attack on alkanes. So they need high temperature or UV light to break carbon-hydrogen bonds. So when this carbon-hydrogen bond undergo homolysis in the presence of UV light or at high temperature, they generate free radicals. So as a result of the generation of free radicals, alkanes undergo free radical substitution reactions. For example, chlorination of methane. Now in case of alkenes, they consist of carbon-carbon double bond system. Due to the availability of pi bonds in these alkenes, they attract electrophiles, as a result of which they will undergo electrophilic addition reactions such as chlorination of ethene. So due to the presence of non-polar carbon-hydrogen or carbon-carbon bonds, alkanes undergo free radical substitution reactions, while alkenes, due to the availability of electron-rich systems, that is pi bonds, they will undergo electrophilic addition reactions. Let us quickly give us a glance of free radical substitution reactions of alkanes. The free radical substitution reactions in alkanes, it involves three steps: initiation, propagation and termination. The free radical chain reaction will be initiated by the formation of a free radical, that is chloride radicals. So here chlorine undergo homolysis in the presence of UV light or heat and it gives two chloride radicals. The generated chloride radical, it attacks alkane, that is methane, in the chain propagation step. Now to get this stability, this chloride radical, it needs one more odd electron. So this odd electron will be abstracted from carbon-hydrogen bond which is present in the methane. Carbon-hydrogen bond consists of a pair of electrons. So chloride radical, it will abstract the hydride radical and leaving the methyl radical behind. So that is how in this step methyl radical will be generated with the formation of hydrochloric acid as the byproduct. Now once methyl radical is generated, immediately this radical, it undergo coupling reaction with the chloride radical which is generated in the first step. And this is how, by the association of methyl radical and chloride radical, there will be formation of methyl chloride. That is how this free radical substitution reaction will be terminated by the formation of charge-wise neutral molecule, that is methyl chloride. Now in this reaction, formation of alkyl radical, that is methyl radical, is considered to be rate determining step. That means step 2, chain propagation, is the rate determining step in this free radical substitution reaction, because how fastly or how easily the product, that is methyl halide, is going to form, it depends on how easily methyl radical will be formed in the chain propagation step. As the overall rate of the reaction depends on how easily or fastly methyl radical is formed, the chain propagation step is known as the rate determining step. Now let's look into electrophilic addition reactions of alkenes. So this reaction also involves 3 steps. Electrophile attacks pi bond. In the second step, carbocation will be formed, and in the third step, nucleophile attacks to give addition product. Let us consider chlorination of ethene as an example for this reaction. So in the first step, chlorine dissociates to give a positively charged chloronium ion and a negatively charged chloride anion. So the positively charged chloronium ion will be acting as electrophile, and it attacks on the carbon-carbon double bond system, that is on the pi bond which is present in ethene. As a result of which there will be formation of a carbocation in the next step. So while making the bond, chloronium ion utilizes the pi bond electrons. So it makes, let us say, bond with this carbon, so that the other doubly bonded carbon becomes electron deficient, so that there will be generation of positive charge on the second carbon, and that is how there will be formation of carbocation. Now in the next step, the negatively charged chloride ion which is generated in the first step will be acting as nucleophile, and it attacks on positively charged carbon of the carbocation, and that is how there will be formation of an addition product. So these are the 3 steps involved in electrophilic addition reactions of alkenes. Electrophile attacks on pi bond, which results in the formation of carbocation, and then nucleophile attacks to give the addition product. Now let me quickly revise this topic, alkanes versus alkenes. Alkanes are saturated hydrocarbons containing carbon-carbon and carbon-hydrogen single bonds, having the general formula of CnH2n+2. Coming to the nature of bonding, they basically consist of sigma bonds which are of non-polar covalent bonds. And due to the presence of these non-polar covalent bonds, their reactivity is relatively low. Hence, the highly energetic particles such as free radicals can attack on carbon-hydrogen bonds. Hence, they will undergo free radical substitution reactions. In case of alkenes, these are the unsaturated hydrocarbons containing at least one carbon-carbon double bond in their structure. That means they consist of both sigma and pi bonds, and they are having the general formula of CnH2n. Due to the presence of pi bond in their structure, they are having high reactivity when compared with alkanes. And due to the availability of pi electrons, they are considered to be nucleophilic species, hence they will undergo electrophilic addition reactions. So now you know alkanes need radicals to react, and alkenes can't resist electrophiles. Next time you see a hydrocarbon, you will instantly guess its reaction style. If you found this battle fun and helpful, hit like and subscribe for more quick chemistry topics. Thanks for watching and stay tuned to my next videos.